So h of x equals the absolute value of 3x minus 4. They're asking us to find what it's called an inner function, and they want us to call it g of x, and they want us to find what is called an outer function and call it f of x. An outer as f of x equals. Okay, what is all this? So I'm going to go back to a previous example we had. So obviously this is g is the inner function because it's applied first. I applied it first to x, or even better, maybe even here it's better. So f come g of 2. What did I calculate first? I had to calculate g of 2. So this is the inner. G is the inner function because I had to calculate g of 2 first. And of course f is the outer because f was applied at the end. After I determined g of 2 and I got 3, I applied f to 3 and it's done. This is the last function applied. Inner, outer. So now, looking at this problem, if I'm asked, let's say, to evaluate this function for 0, what will I do first? Of course I have to do 3 times 0 minus 4 first, and I get negative 4. And then I apply the second function, or the outer function, which is the absolute value of x, to this number that I get. So the inner function will be 3x minus 4, and the outer function will be the absolute value of x. I'd like us to practice, let's say 78. This is extremely helpful and useful for students who move on to Math 230. Extremely important. Okay. We are asked to find an inner and call it g of x, and an outer and call it f of x. There is more than one correct answer here. Does anyone want to give it a shot? It's okay if you're wrong. A shot to the inner and outer. Anyone wants to give it a shot? Anyone? Which function will you evaluate first? Let's say you're asked to evaluate for 0. X is 0. Which function will you evaluate first?
X squared.
Yes. So one option would be that I have to evaluate 5x squared plus 3. And now, where's my prop? I got a number. This is a number now. What function I apply to this number? What function? Of x. That's it. Very good. Let's look at an application. Stop me if you have questions, please. So let's look at an application with a graph. Would you like to choose this one or this one? You choose. Questions are similar. Any preference? Okay, I'm going to choose this one, and I'd like to choose 92 on page 311. And I'm going to copy quickly the graph. Not a big deal. Okay, so this is a v function. And this is f of x. And the other one is a linear function. and it's this. And this is g of x. And in problem 92, we are asked to determine f comp g of 1. F comp g of 1. What do we need to determine first? What do you think? Anyone? Well, obviously, we have to determine g of 1. So f of g of 1. G of 1 is determined in this way. I look at 1, I draw a vertical line through x equals 1, or at least imagine that I draw a line through x equals 1. I see it crosses the graph of the function in a particular point, and I will be reading the y value here. And from the graph, the y value is -5. So this is -5. At this point, I have to determine f of -5. So I go to -5, which is here. I draw a vertical line, or at least imagine that I draw a vertical line. I see that the vertical line at -5 crosses the graph of function f at a particular point, and I will be reading the y value. From the graph, the exact value is 3. So this number equals 3. So this is how we use the graph to evaluate the function composition. The graphs of the two functions were given to us. Another illustration of function composition. Let's look at a word problem. On page 312, yes. So let's look at 101 on 312. And let's read it. The regular price of a computer is X dollars. I take notes. So X, regular price. In dollars, of course. Let f of x, we are given f of x, which is x minus 400, and we are given g of x, which is 0.75x. Part A. Describe what the functions f and g model in terms of the price of the computer. So, can anyone analyze f of x and say, oh, I know, f of x is doing this to the regular price? What would that be? If x is the regular price, what x minus 400 will represent? What would that be? Well, a discount of 400. From the regular price, we get a discount of 400. Part B. In Part B, they want find f comp g and describe what this models in terms of the price of the computer. Fine. So for finding f comp g, I have to find f of g of x by definition. I have to replace g of x, the inner function, first. So this is f of 0.75x. I look at f, and f says whatever minus 400. But this is my whatever now. So 0.75x minus 400. Now what does this represent in terms of the price of the computer? Can anyone tell us anything about it? Any ideas of what it means? Anyone? Anyone wants to say anything and wants to help? Okay, but well, what it means is that we are getting a discount of 25%. We are only paying 75%. This is a discount of 25% on the regular price. Or if you want to say, we pay 75% of the regular price. However, this is not all. And then a discount, a furthermore discount of 400 is also applied. Good deal. So from the original price, we get a discount on 25%, which is we only are charged 75%, but in addition to that, on top of that, they reduce the price furthermore from this another $400. Now they're asking us to repeat the same thing for G comp F. Let's do that. So part C is the same problem, but now they want us to determine G comp F of X. By definition, this is G of F of X. I have to replace F of X now. So G, F of X is X minus 400. And now I stop and I look at G. G says G of whatever is 0.75 of whatever. Okay, fine. 0.75 of whatever. So this will end up, after I distribute, 0.75x minus, and I multiply 0.75 by 400, and I get 300. So then, what does this mean? It means that the same thing, a discount of 25%, but then only $300 off from that of that price. So I think it's better if I say that. You understand what I'm saying. And now finally in part D, they're asking us which one is the best deal. Well, it's very easy to decide which one is the best deal, because this one has 0.75x minus 400, this one has 0.75x minus 300. So of course part B is better for us, for the customer. Okay, that completes everything I had to say about algebra functions and function composition and decomposing functions. Do you think we need other examples? Is there anything else that you would like to go back to? If not, I'd like to move on to 2.7 inverse functions. I like to present 2.6 and 2.7 together because they are linked together. And the last section has nothing to do with most of the chapter. Totally different. So should I wait? Is anyone going to ask a question or moving on? Okay, well, you can stop me anytime. Inverse functions. Inverse functions. What does this concept mean? First of all, when we started talking about functions, I presented three different bubbles, sets of bubbles to you. I presented this, I presented this, and here's another set, and I presented this. Which of these is or which are functions? Anyone remembers which of these are functions? Number 1, number 2, number 3. Anyone? Is anyone paying attention? Anyone? Okay. This is the function. This is a relation. And this is a function. We don't talk about this one. This is done. But these two are both functions. But only this one is called 1-to-1. Meaning each y value corresponds to only one x value. Going backwards, each y value corresponds only to one x. This y value corresponds only to one x. This one is a function, but not, in short, we write 1-to-1. Not 1-to-1. Why? Look here. One y value goes back to two different x values. Function, but not 1-to-1. So the reason why this is important is because only 1-to-1 functions have inverse functions. This one has an inverse as well, but it's not a function. But this one has an inverse that is a function. So if I consider this x, it will go to 1y. If I consider this x, it will go to 1y. If I consider this x, it will go to 1y. So that's the first concept we need to discuss. Only 1-to-1 functions have inverse functions. Note, only 1-to-1 functions have, we can say inverses, but just to make sure, this is an inverse as well, but it's not a function. Have inverse functions. How do I know from a graph? I know from the bubbles which function is 1-to-1. But how do I know from a graph if a function is or is not 1-to-1? We know so many functions now. I can graph a lot. That's enough for now. So what does 1-to-1 mean? 1-to-1 means to each y value, it corresponds only one x value. Only one x value. I know that these are all functions by the vertical line test. They are all functions. Now, how do I determine whether they are 1-to-1? By the horizontal line test. For this y value, 2 x values, not 1-to-1. For this x value, 3. For this y value, 3 x values, not 1-to-1. For any horizontal line, yes, 1-to-1. For any horizontal line, yes, 1-to-1. How do I determine, let's suppose, I know now already that linear functions, radical functions, linear, radical functions are 1-to-1. So let's choose a linear function. Give me a linear function, please. And let's determine its inverse.